Hey guys, we're back with another video. This time we're doing chapter 8.2. So here we've got a question. Jeffrey borrows $3,500 at a rate of 6.5% per annum interest compounded monthly, which is to be paid back with monthly installments of $711.42. Part A asks us to write a recurrence relation to describe the situation. So here's our recurrence relation. A n plus 1 equals r. Now this little r here represents the common ratio, just like in our geometric sequences from earlier in Unit 3. This is our common ratio. So the common ratio times the value of n, or the previous value of a, essentially, minus r. Now, we've got little r and big R. Big R, it stands for repayment, or you can put MR, monthly repayment. A0 is equal to A. Now, to complete it, all we really need to fill in is little r, big R, and a starting point, somewhere to jump off from, and that's our A0. So going through the question, the A0 is going to be 3,500. That's our starting amount. Our common ratio. Now here, it's 6.5% per annum interest. It's compounded monthly. So again, if you just made your ratio 0.065, that's incorrect. Okay, and then, sorry, I'll put the times in for this one. You can't just make it 0.065. Okay, first of all, we're dealing with repayments and interest compounding monthly. And here what we have is a yearly rate. Okay, so the first thing we can do is take our 0.065 divided by 12. Now, I'm going to have to round. I could round this, sorry, is what I should say. I'm not going to. I'm going to divide it by 12 so I get a more mathematically correct answer. Now, the next mistake that students make is they look at that and they say, no, that's what, that's the interest, that's what it's increasing by. This gives us a model of decay by using 0.065. So we have to actually go up here, or overall, I should say, and we have to add 1 to it. Now, I'm going to put that in brackets so we know to do this first. There we go. So that's our R value. Now, again, you could round it, but we're just doing this to get the most succinct answer here. No need for AN. And then R, the repayment, is 711.42. Now, if you're wondering where they got that number from, for a general maths level, you do not need to know. But in a later video, I'm going to be showing you how they calculated that using the annuities formula. Anyway, continuing on, that is our recurrence relation. That's all we have to do. We're done. We can move on. Use your calculator to determine the number of monthly repayments needed to pay off this loan. Well, they might go, well, $3,500. Divide that by, 711. That's going to take about 5 repayments. Now, that may well be true, but remember, that's not taking into account the monthly repayments, and we have to use this recurrence relation here to figure it out. So to start with, let's go with A0. So I will skimp on the working in just a minute, but I'm just setting it up for you. So with this recurrence relation, what we can do is we can now find 0 plus 1 is 1. A0, that's our starting point, is 3,500. Now, when I enter that into the calculator, I'm just going to quickly do so now. Now, I'm just going to quickly copy this down. I'll do 2 steps for this one, and I'll talk you through the different answers we get. We do this highlighted section first. Just going to make sure I'm recording. Yep, good. We do this highlighted section first, and that's going to give us $3,518.96. Now, comparing it, basically what this is, we've calculated a month's worth of interest before the repayment is made. Now, what that tells us, if our initial starting amount was $3,500, that means there's $18.96 interest. Again, I know the question doesn't ask us this, but this is just a good little a point to see what we're actually figuring out as we go. Now, what I'm going to do is take away $711.42. What that's going to do is it's going to give us an A1 value of $2,807.54. Now, that's all well and good, There's the working for the first one. I'm just going to quickly, using some shortcuts on my calculator, I'm going to go through and work out the rest. Actually, I might just do one more so I can show you how I'd substitute the next one. So here, now we want to find A2, so A1 plus 1. That's the working for this one. Substituting it, you're going to get this. A1, we knew what that was worth. That was 2807. Now, again, I'll show all the working for this one again. A3, A4, and if we needed A5, I think we will need A5. I'll skimp on a little bit, just to speed up this video for you. Now, when you enter this into your calculator, this is what you're going to get, 2807.54. You're going to end up with the following. Just delete that. 2822.75. Now, what we can see straight away is this time, originally, in the first one we gained 1896 interest. Down here, you can see that's already dropped to approximately 15, maybe just over $15 worth of interest. Now, the reason the interest has gone down is because our principal remaining on the loan has gone down. Okay, so that's just a cool little tidbit of information for you. What that's going to do, we go A2 minus 711.42. Units 2,111.33. You follow this same process for the rest of these now. I'm just going to work them out. So for A3, I might just delete this first line of working so I can fit them all on this page, hopefully. Actually, I'll just save this so I won't do that. For this one here, we get 1,411.35. Rounding can play a minor role in this, but not too bad. Hey, we might fit them all. We're going to fit them all. For A4, again, just going through the motions now. $707.57. 58 cents with rounding, sorry. Going through the next one. Now, it's worth noting that what I end up with, similar to this, I get 711.41 minus 711.42. That's actually going to give me negative $0.01. So as you can see, that's effectively zero. Rounding absolutely had a bit to play in that. And sorry, I just realized I called this A3. This should be A5. By the end of our fifth payment here, we end up with negative 1 cent, or basically zero. Again, you will always be given this information. You should never be asked to find that repayment. It's just a number they've given you. I will go through for the kids who want to see how it's done later, and I'll show you that annuities formula. But there we go. Number of monthly repayments, as I've just said, is 5. Okay. Quite a lot to repay for a monthly amount, but must be a quick short-term loan. Okay, so here Mimi takes out a loan of $1,500 at 9% per annum to buy a new computer. The loan is to be paid back monthly in equal installments of $382.06. The incomplete amortization table for the loan is below. Now, what we're going to do is we're going to complete this because this is going to help us answer the 2 questions here. Now, I'm actually going to use the help of Excel here. Okay, I will sub all the values in for this one. Now, the first thing we know is that all of the payments are going to be constant. Okay, that doesn't change. The amount we repay towards the loan every month, or every installment, is going to be the same. The interest we have to work out, but again, I will go through that in just a moment. How much the principal is reduced by after each payment, and then I guess what we have finally is the balance of the loan. So now this could be interesting in terms of how they want us to set it out. There's two ways that we could go about setting it out. I'm just going to go back to the example in the textbook here. So 8.2, this is where we're working from. We've answered that first one. Yep, okay, so here they just do 0, 0, 0. It's interesting to note, sometimes these tables at payment 0 can actually calculate the interest, and it kind of chops and changes halfway, but here they don't. They just say, okay, hasn't reduced. The balance at the end of this is going to be $1,500. We haven't charged anything. Now we can get this underway. So here, with the balance of the loan, okay, we've got it at $1,500. Okay, what we have to do first is we have to calculate the interest on that. Okay, now we know the payment's going to be $382.06. Okay, but we don't add that. Take that just yet because it's a repayment towards the loan. We have to calculate the interest. Now, what we can do is we can actually use a recurrence relation to go about solving this one. Now, what I'm going to do is I'm just going to put the first line in before I jump to Excel and show you how much easier it is to do in Excel. Now here, as it awkwardly formats itself, we'll try and get it back to the way I want it to here. I might even just have to drag this for a minute. Okay, I'll go through and fix it up a little bit later. That's not a problem. Just stretch this out for the first line of working here. Stretch this back. Okay, so for this one, what we're going to do is substitute A0 plus 1 equals this. The interest rate we're dealing with is 9% per annum. We're doing monthly, so it's going to be 0.09 divided by 12 to give us 0.0075 in this case. I don't need to divide by 12 anymore because I get a nice even number. We add that to 1. Now here we're doing it to a 0. Now the repayment, I know I've just copied and pasted it. We're not subtracting $711. The repayment, as you can see, is $382.06. So I'll leave this kind of first line of working in this question for you. Okay, this time it's going to be A0, which we already know is $1,500. This is going to be A1. Let's see what we end up with. So $11.25 in interest is what we end up for the first month. The overall value, once we've subtracted the 382.06, however, is going to give us the following. Now, what I've done is actually just realized, I've just done the balance of the loan here. If we just wanted to find the interest, we wouldn't need to subtract this. My apologies. So the interest alone, just for this one here, what we can do is actually minus the $1,500 after that, because that takes away our original principal. As I said earlier, $11.25 interest is what we get there. Principal reduction. In this case, I'll just double check how they've gone about it. Oh, so how far they've actually gone down. So here, we haven't gone down by $382.06. The total reduction is actually equal to, just copy a shorter formula here. It won't be this long, don't worry. The reduction is actually just going to be equal to, normally we'd take away $382.06 every single time from our principal, and that should be the reduction. But you have to realize that the reduction isn't going to be that amount. It's actually going to be smaller. We've taken less away because of the $11.25 in this circumstance. Okay, well, that's going to give us so 382.06 minus 11.25, $370.81 is what we end up with in terms of our principal reduction. Okay, now what you can do then is obviously the 1500 take that. There's a number of different ways you can do it. I'm just going to do the 1500 plus 1125 minus 382.06 to get what I typed in earlier, the 1129.19. Now, what you're going to see, I'm not going to fill in the rest of this because I'm going to show you how easy it is to do on Excel now. Now, I also was going to do this one on Excel, but I might not. I'll just do this one. So what I've done is I've copied the table here, so you can see the headings line up. Now, what I'm going to do is just copy in the first line. So the payment was, as we said earlier, 382.06. I'll change all of these here, sorry. I know we're probably not going to use this many, but I'm just going to change this to currency. Hopefully it doesn't hate me too much for that. I might zoom in a tiny bit as well to make it easier for you guys to see. So we've got 0, 0, and then $1,500 for that one. Now, the 382, as I said earlier, is a constant. I'll just go down. We won't need all of these, but I'm not going to sit here and reveal how many payments. Well, it only goes to 4, so I guess we'll only go to 4 for this example, and we'll see how we go. So, first thing is I need to calculate the amount of interest paid just after the first month. So normally we use our compound interest formula, but again with Excel we want to try and make it as easy as we can for dragging and dropping, and that obviously goes the same for using things like constants and clicking on cells. So the very first thing we're going to do, because it's a geometric sequence here, to find it, we always start with an equals. Now, to find the interest, what I'm going to do is start with my rate, 1.0075. If you're wondering where I got that from, you can see the working for it just here. Now, with that, what we're going to do is we're then going to multiply. I might just widen, oops, I'm just going to widen this, just so you can see the full Excel formula. I know you can see it up here, but I'm just going to make it easier. Equals 1.0075. What we're going to do is multiply that. Now, this is where I'm going to click a cell, because the thing we have to realize is our principal that we're calculating interest on is going to change every time. So I'm going to click on E2 in this case, which is $1,500. And what that's going to do, we're then going to take away that principal. There's the 1125 that I mentioned earlier. In terms of the principal reduction, what that was equal to in this case is our constant payment take away the interest. Okay, 370.81, 370.81, it lines up. To find the balance of the loan, in this case what I'm going to do is go 1,500, adding the interest, and then subtracting a repayment to get 1129.19. Notice how it matches up. Okay, now we still have to do, I wonder if we have to do another line. I don't think we may not have to. We may just be able to drag and drop this. And what I'm going to do is I'll do some troubleshooting and see if we have any particular issues with this one. Okay, so interest, so let's just go and double check our formulas. For those who missed how I dragged and dropped, you get the little black bar here, drag and drop. Now, let's see. Yep, but then our last payment kind of shoots up. So we might have to investigate that, but we'll do that in just a moment. So here, let's start with this one. Yep, so the 1.0075 times E3, which is that one, minus E3. Yep, that gets us our $8.47 interest. This is B4. Yep, take away that. Okay, yep. Oh, no, it's all increasing, sorry, not decreasing. So, yeah, this is correct. And you'll notice at the very end, we get the negative 0.01. It'll vary, obviously, depending on how you've worked it out, but that's what we end up with there. And that's our table complete for that one. So I'm just going to quickly copy and paste these in. I might leave those formulas there. This actually condensed pretty well from what I can see. I might just shrink this a bit so this can fit in. Yep, there we go. So I'm just going to sub the rest of the values in. So 1125, yep, 847. Remember, it is good to learn how to do it on technology, but you won't have access to this technology during an exam. So we do need to learn the paper method here. And 284. So then it's probably going to be easier, actually, to do I could try copying them all in one go, but I don't want to have it make a mistake when this will only take me another, 10 seconds. Because now, and the reason I'm copying this back is so I don't have to keep on flicking between the two. So, what is the total interest paid on this loan? Well, using our table here, okay, I'm just going to quickly copy a formula. So, total interest in this case is just going to be the sum of all of these. So that's going to be equal to 11.25 plus 8.47 plus 5.67 plus 2.84. Again, because I want to show you Excel as well, let's just sum them all to help answer our question. 2823. Okay, so again, copying, pasting. $28.23 for that one. Okay, so there's the answer to part A. That's the total interest that we paid on this. There is another way that you could have actually. Just trying to think if that'll work. Yeah, I think that'll work. Yeah, absolutely, that'll work. There is another way you could have gone about working this out too. I'm just going to talk about it, not going to write it down. This payment up here, what you could have done, I'm just going to double check to make sure it works too, if there's any rounding errors. What I'm going to do is times that by 4, because we, as you can see, we made 4 equal repayments of $382.06. Sorry. You times that by 4, we end up with $1,528.24. What we can then do is take the $1,500 away from that, and we end up with $28.24. Close enough, just 1 cent difference in terms of rounding, and that shows just down here as well, so that's all fine. But that's the other way you could have worked out that if you didn't want to go through and make this whole table. In this case, as part of the question, I did want to do this table, so that's all good. B, what should the amount of the final payment be to ensure a balance of 0 at the end of the final payment to ensure a balance of 0 at the end of the loan payment? Well, here, if we just made a repayment of $382.05, we've obviously paid 1 cent too much. Okay, that would get our answer for that one. So I'm not going to put a whole formula for that one. That one's actually pretty straightforward, and I wouldn't expect you to show working for something like that. If it were a bit more complicated, asking for different maybe adjusting the monthly repayments. If they made an error there, you could potentially look at that, but we shouldn't ever get you to do that. So just decrease the last payment by 1 cent. That'll get you to exactly $0. And that's it for the video, guys. Bit of a longer one with 8.2, but with these reducing balance loans, it is important that you understand the mathematics behind it, as well as how to set it up on Excel with all the different formulas. Anyway, thanks, guys.